Hi everyone, so today we are presenting our CNN model on classifying galaxy images. This is a table of content and these are topics that we cover in this presentation. Our problem statement is that what are some approaches and strategies that we can possibly employ in our CNN model given a data set of 10 different classes of galaxy images. So we first got our images from the dataset, and then we realized that it is too large for our laptops to process it. So we split the dataset into separated image files. And then we noticed that the dataset is actually very imbalanced. For example, some classes will have significantly less data images than other classes. So we used weighted class approach to solve that problem. And then we use morphological transformation as our image processing techniques because in the original data set, which is Galaxy Zoo, they use morphological characteristic to classify galaxy images. And then we build our CNN model, which with 80% of the data split into training data, and then 20% were split into validation data. We also use some callbacks to avoid overfitting problem, such as early stopping and checkpoints. The chosen algorithm in this project is DenseNet 201. It is a pre-trained architecture for transfer learning in image recognition. We chose it for its higher parameter efficiency and its dense connectivity, which means each layer receive feature maps from all its preceding layers. This results in higher efficiency of information flow throughout the network. Our data set is Galaxy 10 decal data set. It is originally developed from the Galaxy Zoo data. The version that we use uses the images from decals, which has higher image resolution and better image quality. And the images can be classified into these 10 classes.
As for the code implementation, we use standard Python libraries such as TensorFlow, NumPy, Pandas, and some additional libraries for visualization. To train our model, we use GPU resources in Google Colab, but it is not very stable, so we also write a customized callback to save the best model to Google Drive after every epoch. We use it with model checkpoint so that we can get a better training experience on Google Colab. In image data generator, we defined a pre-processing function to reduce the noise. We then train our model for 50 epochs. As you can see from the middle plot, the model converged quickly for the first 20 epochs, and then the performance improved slowly. After training to get a better understanding of our model, we use Silence Map and GradCam to interpret our model. As you can see from the GradCam, the model sometimes gave wrong predictions based on the strange features on the edges of the image. As for the final result, our model gets a total accuracy of 78% on test dataset. We also plot the confusion matrix. As you can see, the model performs pretty well on most classes, but for class 0, class 2, and class 6, the model makes more mistakes. To conclude, we learned about how to apply transfer learning to build new models for different classification tasks. We also learned about it is very important to have a balanced training dataset to get a better performance on every class. And to some extent, pre-processing method can improve model performance and speed up the training process. As for possible improvement, we could try more different pre-trained models to get a better performance. We can also use more callbacks such as scheduled learning rate to speed up the training process.